looking at today is now applications of differentiation. We're good at taking derivatives, but now we need to talk about what we can do with it. And what is going to end up happening is using a lot of information of a function, the derivative of the function, and the second derivative of the function, we should be able to find lots of things. Everything we did from trig, asymptotes, holes, domain, range, that sort of stuff. Extrema, which is what we're going to talk about today, which deals with maximum and minimum values, increasing and decreasing regions, and something called concavity. So let's start with extrema. Now all extrema means extreme values, and extreme values are maximum or minimum values that appear on a graph. And what we can have are local maximum and minimum or absolute maximum and minimum on any region. So looking at this graph, these are all local maximum and minimums because I'm hitting a little peak. It's bigger than everything around it, or it's smaller than every other point around it. Now the absolute maximum minimum are just that, the ones that are the absolute biggest of all the maxes or all the minimums. So this one's an absolute maximum because it's bigger than all other maximums in the entire place. Same with this with the absolute minimum. Now the one thing that we need to look at is we always need to include an endpoint when we include this. So for example, if say maybe on this side here, this guy extended all the way down to here at the endpoint. Well, it's now below this absolute minimum. This would become now my new absolute min as an endpoint, whereas this would now become just a local minimum. So those are just a couple little things to look at. Other part too, if this was an open circle here, then we can't look at an endpoint because there is no endpoint to look at. So those are just a couple little things that we'll go into more detail as we go along. Okay? And what I really want to talk about is thinking about slope of a function. Because slope, as you notice here, as I'm going on this function, I'm increasing here. This is going up, 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 up. That means its slope is positive. Well, now here it's going negative. What happened in between? We had something that was a maximum. This would be, looks like, well, probably a local maximum. But what I want you to notice here is that the slope at that point would have been 0. Well, remember, slope means derivative. So what we're going to see here is that when the derivative equals 0, that means you're going to have a maximum or a minimum value possibly happen. In this case here, we're going from negative, negative, and then all of a sudden we're going back positive again. We again here have a slope of 0, and look what happens. We have a minimum value here. Okay, now the one last part. We're increasing here, we're decreasing here. So what is this slope right here? Don't say it's 0. Over here we're increasing and it's a sharp turn decreasing. Remember we called that a cusp. That was someplace where the derivative could not happen. This is where the derivative does not exist. But even when it doesn't exist, this is still a maximum because it's bigger than everything around it. So what's happening here is that we're going to have a maximum or a minimum value occur in different places. They can occur when the derivative equals 0 or when the derivative does not exist. So if I say in this problem here, finding extreme values of a function, I'm just going to take a derivative of this function, so 2x minus 4, and then what I need to do is to say first, are there any places where it's undefined? No, there's no undefined spots, but then is there any place that equals 0? So I'll set 2x minus 4 equals 0, means 4 equals 2x, which means that I'm going to have x equaling 2. I should have a maximum or a minimum possibly happening at the point when x equals 2. Alright, and we'll go into more detail in our next lesson here. It's called the first derivative test, about how to claim and how to figure out whether this is for sure a maximum or a minimum, which one it is.